All right, so now we're going to go ahead and finish up a couple things for this chapter or this module. The next thing that we're going to look at is rounding whole numbers. This comes from section 1.7 of your textbook. Let's go ahead and see what this involves. So in this section, we're going to go ahead and formalize what we mean by rounding. So our procedure in order to round, the first thing we want to do is identify the digit in the column of the place being rounded to. The easiest way to do this is go ahead and underline it. This is the digit that we're going to be working with. Now, in order to determine how to round, we're going to look at the digit to the right. If it is 5 or more, add 1 to the digit from step 1. We call this rounding up. If it is less than 5, please note that we do not subtract. We leave the digit from step 1 alone. We call this rounding down. After we finish with our digit, doing something to it or leaving it alone, the next thing we want to do is replace all digits to the right with zeros. Okay, so let's go ahead and look at some examples. If we look at example A, the first thing I want to do is I want to identify the digit that is in the hundreds column. So this is 349. 3 is in my hundreds column. We are going to look at the digit to the right, the 4, and we want to know, is this 5 or more or less than 5? 4 is less than 5, and so remember that if it is less than 5, we're going to round down, meaning I leave my 3 alone, and then I replace all the other digits with zeros, or digits to the right with zeros. So 349 rounded to the nearest hundred is 300. All right, if we look at example B, the first thing I want to do is I want to identify the digit in the thousands place. 6 is in the thousands place. I'm going to look at the digit directly to the right. It is an 8. Is 8 5 or more or less than 5? 8 is 5 or more, so we are going to round up. So what I want to do is I'm going to keep the 3. I'm going to change the 6 to a 7. Everything to the left always stays the same. So we get 37, and then we replace all the other digits to the right with zeros. So 36,833 rounded to the nearest thousand is 37,000. All right, let's try some more just to make sure that we're okay. All right, C, we have 134. We want to round to the nearest 10. What digit is in the tens place? It is the 3. If we look at the digit to the right, it is a 4. That tells me to round down. So I'm going to keep my 1. Rounding down, 3 stays the same. And then we replace all digits to the right with zeros. So we get 130. All right, let's look at example D. We have 73,077. We want to round to the nearest hundred. So what digit is in the hundreds place? It is a 0. We look directly to the right. We have a 7. That tells me to round up, so I'm going to have 7, 3. I'm going to add 1 onto the 0, so it will become a 1. And then I replace all the digits to the right with zeros. We end up with 73,100. All right, last two. These ones are some of the ones that are a little bit trickier. And what it entails is it entails rounding a 9 up. So let's talk about how we do that. So our procedure is going to be basically the same. First thing we want to do is identify the place being rounded to. We are rounding to the nearest hundred. In our hundreds place, we have a 9. If we look at the digit to the right, it is a 6. And a 6 tells me I want to round up. Now, we run into a little bit of a problem because I can't add 1 onto 9. That gives me 10, and I can't have a digit of 10. So what we need to do is we need to move to the left, not think of it as a 9, but think of it as a 39. You only need to go as far as a number that you can actually add 1 onto, okay? So I can add 1 onto 39, and we're okay there. So if we go ahead and do this, we get 1. I add 1 onto 39. That becomes a 40. I replace all the digits to the right with zeros, and so we end up with 14,000. All right, let's try one more just to make sure that we've got it. All right, so example F, we have 14,598. We want to round to the nearest 10. So 9 is in the tens place. If we look at the digit to the right, it is an 8. Tells me to round up. I can't add 1 onto 9, but I can add it onto 59. So what do we get? We get 14. We bring down the digits to the left. We add 1 onto 59. We get 60. We replace all the digits to the right with zeros. So we end up with 14,600. Okay, so that takes care of our basic rounding. Let's go ahead and look at one last thing for this section. The last thing we want to talk about is front-end rounding and estimating. Front-end rounding, what we're going to do is we are not going to be told which digit or which column value to round to. Front-end rounding is we want to round to the front of the number, or always the leftmost digit. If you do this correctly, you should have only one non-zero digit in your number followed by zeros. Now, front-end rounding is actually something that we're going to apply to other problems. We use it to estimate answers. Estimating an answer involves rounding the numbers and then doing the operation. By using front-end rounding, you are making the numbers as simple as possible and hopefully creating a problem that you can complete with very few computations. The benefit of front-end rounding is you should not have to bring out long division or have to multiply and carry and borrow and all those complicated things that we get when we talk about addition, when we talk about these operations. Now, one thing to note is there is a difference between rounding an answer and estimating an answer. Rounding an answer means that you always perform the computation and then round. Estimating an answer means you round the numbers and then perform the computations. Rounding, we will get into this later on this semester when we start talking about decimals. It comes out mostly when we talk about dividing decimal numbers. Before we get into problems involving estimating, let's just go ahead and do a couple practice problems involving rounding using Frontend Rounding. So example A, we have 4,078. The first thing I want to know is what digit is in the front of my number. This is the 4. This is my leftmost digit. This is the digit that I want to round to. If we look at the digit to the right, the digit to the right is a 0. And so do we round up or down? 0 is less than 5, so we're going to round down. I'm going to leave my 4 the same. And then I replace all other digits with zeros. So notice I have one digit that is not 0 followed by a bunch of zeros. This is correctly rounded. Let's look at a couple more. Let's look at 46,364. Same thing. What is my front digit? It is the 4. Please note it is not 46. We're not rounding to the highest period. We are rounding to the leftmost digit. And digit means 1. So we have 4 is our leftmost column. If we look at the digit to the right, it is a 6. And it tells us to round up. So we're going to take the 4, make it into a 5, and replace all other digits with zeros. We get 50,000. And finally, example C. If we use Frontend Rounding, the digit in front is a 2. If we look at the digit to the right, it is a 6. It tells me to round up, so my 2 becomes a 3. And then I replace all digits to the right with zeros. We end up with 300,000. Okay, so now let's go ahead and take this and apply it to some other problems involving estimation. So if we look at these, what we want to do is we're going to talk about estimating the answer, and then we're going to find the exact answer. So example A, we'll start with that one. First thing I'm going to do is just write it out, because we are going to be doing both estimate and exact. So I'm going to go ahead and write out my exact problem before I do my estimation. I'm going to go ahead and write this so that my numbers that have the most number of digits are on top, and I'm going to decrease as I go down. So this is what I end up with. Okay, now I want to go ahead and take these numbers and round using Frontend Rounding. So 3,825, this is going to round up to 4,000. 2,389 is going to round down to 2,000. 565 rounds up to 600. And 72 rounds down to 70. So now that we have that, you should see that this is going to be fairly easy to compute. So if we go ahead and add, starting on the right, we have 0, 7, 6, 6. Do not round this final answer. This is our estimation. This is our estimate. Okay, so now we want to go ahead and find the exact answer. Estimate, what we're going to do is we're going to use it to kind of check that our computations that they make sense in the grand scheme of things. So if we go ahead and do the exact answer, let's see what happens. Starting on the right, I get 9 and 2 is 11, 5 and 5 is 10, and 11 plus 10 is 21. All right, same thing for the next column. If I go ahead and add, I get 8 and 7 is 15, 2 and 6 is 10, and 15 plus 10 is 25. All right, if we go ahead and add this, we get 2. 2 plus 8 is 10. 3 plus 5 is 8. 10 plus 8 is 18. And then finally, our last column, we get 1 plus 3 plus 2 is 6. So our exact answer is 6,851. So now the question that I want to pose is, are these relatively close together? Now, one thing to note is that your exact answer may not round to your estimate, but 6,800 something is close to 6,600 something. So based on our estimate, I would say that our exact computations, we haven't done anything horribly wrong. All right, let's go ahead and try a couple other ones. Let's look at example B. Example B, I'm going to go ahead and start by writing this vertically. And then I'm going to go ahead and estimate. So 6,712, if we round this to the front, this becomes a 7,000. 825, if I round that to the front, we round down to 800. And now if I subtract, I get 0, 0. If you need to, you can go ahead and write out the borrowing step. We get 10 minus 8 is 2, and then we get 6. So my estimate is 6,200. All right, let's go ahead and look at the exact answer. So starting on the right, if we subtract, I cannot do 2 minus 5, so I need to borrow. I'm going to go ahead and borrow from the 1, make it a 0, and make my 2 into a 12. 12 minus 5 is 7. I cannot do 0 minus 2, so I need to borrow. I'm going to make the 7 into a 6 and the 0 into a 10. 10 minus 2 is 8. I cannot do 6 minus 8, so I need to borrow. 16 minus 8 is 8, and then we bring down our 5. So 5,887, is that close to 6,200? Again, it may not round to this answer, but they are close enough together in order for me to say that we did our computations correctly. All right, and the last one we have example C. So if we go ahead and multiply this out, we get 725. times 86. If we estimate 725, we are going to round that down to 700. 86 is going to round up to 90. Now, this should be easy to multiply because we have numbers ending in zeros. Remember that basically what this entails is I just want to multiply my 7 and my 9. 7 times 9 is 63. And then we're going to go ahead and bring down all of the zeros that are in the problem. So this should be 63,000. All right, let's go ahead and find the exact answer and use our estimate to check it. So if we go ahead and multiply starting on the right, we get 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 15. 6 times 7 is 42. And 42 plus 1 is 43. All right, let's go ahead and multiply by the 8. 8 times 5 is 40. 8 times 2 is 16. Plus 4 is 20. 8 times 7 is 56. Plus 2 is 58. All right, starting on the right, we add. We get 0, 5, 3. 4 plus 8 is 12. And 1 plus 5 is 6. So we get 62,350. Is that close to 63,000? The answer is yes. All right, that takes care of our estimation. Make sure that you do know the difference between rounding and estimating, because they will come up over the course of the semester. All right, that takes care of this section. The next section that we will look at is going to be fairly quick. We're going to talk about order of operations.